So, my name is Max, and I'm working at here company. And today we will discuss mostly Node.js streams and a little bit of reactive programming. I will try to be as kind of concrete as possible and provide some samples, because there is a lot of hype about reactive programming, but actually not no examples except something like mapping some mouse clicks or something like that. And also a lot of people asking something like, how can I use it on backend? So I will try to provide kind of small but still useful example of backend of backend project which you can do with ideas inspired by reactive programming. Wikipedia says that reactive programming in computer, reactive programming is an asynchronous programming paradigm concerned with data streams and the propagation of change. Basically, it was invented with a library called Reactive Extensions for .NET, and in kind of narrow explanation, it's every program which uses reactive extensions. In more wider explanation, there is a course called reactive programming on Coursera, and the guy Martin Nodejs explains that every time when you apply functional programming to kind of real-world problems which expect asynchronous programming and I don't know, some concurrency, it's actually will be reactive programming, and there are a lot of techniques to use it, from something like message pattern, which you can see in Arca framework or in R1, to reactive extensions, which you can use in mostly every language. And what are Node streams? Nodejs streams, it's interface written on top of event emitter, which provide you a way mostly to write somewhere and to read from somewhere. There is 4 kinds of streams: readable, writable, transform, and duplex streams. We'll check on in today's talk only 3 kinds of them: readable, writable, and transform stream. Duplex you can check as a homework. So what are our problem? It's very simple, but we do it probably every day. We need to implement a simple web scraper which grabs all the data from some REST API, processes the data somehow, and inserts into our database. I believe everybody do it millions of times. I tried to abstract from actual API implementation and database implementation just to make it a little bit simple. So we have 2 functions. One of them called getAPI. It receives count and offset, and returns you some objects. The pretty thing about this API, there is no easy way to count all the entities in the API. So you basically need to grab them all until some moment when you receive the empty list. And also there is insert DB function where you can put our objects, and you can do it in about the list. In our actual project, it was booking.com API and Postgres database. So you try to provide kind of quick and dirty solution for this kind of stuff. We have a function grab which recursively call getAPI, changing offset until the moment when we will receive empty list of items. The solution will probably work, and it will work. But what's the problem with this solution? It's hard to understand what does it do. You need to read all the code to realize what does it do, and doesn't expose the idea of kind of data flow or something like that. What else? It's too specific. What does it mean? If you add some data processing, the code probably will look a little bit heavy, something like that. The other thing, it's recursive. Actually, not really, because when we are return promise from function, it's actually not recursive solution. There is no idea like we don't have this problem of stack overflow, which will have just this simple recursive solution, because promise here creates kind of new frame in stack. It's kind of part of the specification. But recursive solution is hard to read. And the other thing, it isn't performant. What does it mean? It means that in a case when our get API call is much cheaper than insert DB call, we will need to wait every time until we will finish insert DB call. But probably most of the kind of modern database provide you a way to to insert some data in a bulk. So you want to make as much as possible read call. After that, write it in one call, and it will be much faster. And if you try to do it just by your hands, it will be kind of really pain in the ass. You will take, you will need to implement some buffer, check it, and it will be really hard to implement. So, what our solution? Our solution is just to implement two streams, read stream and write stream. Node.js provide you the primitives, readable and writable, which you can somehow extend. It looks a little bit heavy, but the thing, it's standard primitive. You just implement one function called read, and inside of it function you just call our get API. What are important bits here? In constructor we are calling super, which is object mode. What does it mean? It means that every chunk will be an object instead of kind of chunk of binary data. Yeah, that's all. Yeah.
So rows and size, so size not used, shouldn't be rows.
Rows, what is his size?
So when you call read,
yeah, size don't use. You can use it. It's actually will give you ability to change buffer dynamically, but for this simplified example, we don't use it.
and
So
what is rows?
rows, it's just size of offset, of typical offset. So read from 0 to 1000, from 1000 to 2000, and every chunk is 1000 of rows. Yeah. And we need to implement DB writable, which is also easy. What are important bits here? High watermark is basically the size of our buffer. And the important thing here, in object mode, size of the buffer high watermark, it's size in objects. And there is no clear way to say how much it is in a byte. So just saying it's 5 objects, 10 objects, 1000 objects. Also, you need to provide here object mode, which also will be true because we operated on objects. And there is two functions, write, _write, which are responsible for when we just want to write one chunk, and write v, which is responsible for a case when we want to write in a bulk. So it will create you a buffer, and after first write, it will take all the chunks in a buffer and write them one time. So it will be much faster than code. We'll write 5 times.
What's the advantage of using objects instead of just passing binary data?
It depends actually on situation. Here we want to, in the end, I will add kind of data processing. And for example, you want to filter some object or, I don't know, change them somehow. It will be much easier to do it with just when it's just objects. But if you want to create kind of binary string, it's not a big deal. But okay, the same. Actually don't know the situation where do you want to create such string. I mean, in most cases, it's something implemented by standard library or third-party libraries. So, yeah. But you also can do that. Yeah, and now it works just like this. So you create an instance of writable and readable stream. After that, you just pipe IP readable to DB writable. And when you call pipe, it starts working. The benefit of such code, it shows you somehow a data flow. You just know that somebody takes data somewhere and put it in other place. So, why it's better? It definitely doesn't work eventful. It uses standard library primitives, which probably means that it should be fast. And also it uses buffer and back pressure. What does it mean back pressure? It means that it won't read until it will finish write. So you just fill the buffer, wait until write finish. After that, once again, and fill in the buffer. And yeah, it's really fast and it's really hard to implement by hand. Next, we wanna add some data processing, and it's actually where kind of reactive programming can come. So we'll just remove some. Entries by their ID and just change some entries. Something like if ID is if mod of ID by 3 equals 0, we will remove this entry, and also we will add timestamp for some entry. So how can we do data processing? The easiest solution is just with streams. We can create transform stream by ourselves, or use a library called through tool, which gives us some primitives which we use in functional programming, like filter and map and reduce. Or we can use Nodejs library. Nodejs, what's the problem with Nodejs library? It's definitely not the best place to start. I mean, it can do mostly everything. It's really mature, and I'm sorry. And there is a nice resource called Nodejs Marbles, which provide you a nice diagram of stuff which you can do with Nodejs. There is nothing which even close to this level. It's really nice. You can merge different streams, all the stuff, but it's really hard to work with it. And it's not just something like I will take some data here, and pipe it somewhere here. It's much bigger. And also it provides some primitives which kind of foreign for JavaScript. It was implemented for .NET, after that for Java and Scala, and there are a lot of stuff like schedulers, and if we need another talk just to explain where to start. And there is a nice small library called Kharandziuk. It's actually not so mature, but it provides me a way just to show kind of basics of reactive programming with strings, and it's really dramatic from perspective of JavaScript. So how it works? Here we just wrap our readable with -string, because every time we operate with array of objects, we'll flatten it, so we'll have kind of, instead of one kind of array, it's not array, it's actually a string array of arrays, we will have just one array with one value. After that, we'll just reject all the values which contains 3 in it. And after that, we can map it somehow, just adding timestamp. Why do we need batch timer count? Because our DB writable string was implemented with the idea that every time we pipe in the array of entries, we can implement it in the other way, but it will also work. So we batch in 1,000 entries or entries which we will have in a frame of 100 seconds, and just pipe it in writable string. So why it's better? Just because it's use the same primitives. Reject a filter, map, and you can use reduce or something like that. So yeah, that's all. If you have any question? No question? Okay, thanks. Yep. I mean, actually, I don't have any numbers, but in our particular case, it was something like 10 times faster, just because it's putting all the data inside of, just because it works kind of in better way. Put all the data inside of buffer, after that, write in one batch. Because particular write in Postgres database is kind of expensive, but it doesn't depend on it really doesn't depend on the size of entries. You can write in bulk, and in our particular case, it was 10 times faster. Yeah.
I think that it also is important to note that it's better in performance for memory. So, for example, in our case, we were parsing a lot of CSVs, like big files.
Okay.
And the first approach was put the CSV on memory, and that was like killing the instance. So what we did was to read the string from the Amazon, the CSV, and then we pass it through our custom implementation of pass-through streams. And we were incentively doing async calls, for example, inserting to the database the parse data, and that reduced like from using 2 to 3 gigs to 200 megabytes. So,
yeah, but actually, I expect that it's kind of implied from my code. If you do it by hand, there is no possibilities except implement the buffer by yourself, or write one by one, or write kind of try to read as much as possible and put into some writable string and to write it. And in this case, if you somehow not buffer it, the buffer will grow in a case when the write operation is more expensive than read operation. So yeah.
Yeah, that was actually also my question, because here when you have like the read call that gets potentially like way often more called while you're actually waiting to write it. Actually, the footprint here will be bigger than for like file system calls where you have like this stream, like the read stream thing has like internal buffers that only reads like chunks of data which you can process in CSV. But here you would actually have a lot of pending objects waiting for you to be processed. Right?
Yep, but the amount of this pending object will be not bigger than size of your buffer, high water mark. So it just write until you fill the buffer, and after that try to write it as a one operation. So it's the main thing which strings provide you, that it will buffer it and try to write as one operation. And basically.
How does the buffer, how does the read stream actually knows about the high watermark of the write stream? And in the point in time where you're calling the read, the underscore read, you actually don't know how many objects that call will yield, right? I mean, it's like a promise that will eventually resolve.
It's actually the reason why it's called high watermark. Consider a tank, and you have kind of high watermark. So you're filling this tank until the moment when high watermark, when you exceed high watermark. After that, you throw the water out.
Yeah, sure. I mean, you don't know whether the one call to read will return to like one object or 1,000 objects.
Yeah, you never know actually. I mean, how can you do that? If you call in the API and API returns you, it's probably kind of the matter of underlying implementation of the, I don't know, request library or something like that, which also use some kind of binary stream, which will call something and try to stream it. But if the API returns you, I don't know, 2 GB object or something like that, what can you do with that?
If I remember correctly, the way it works is that as soon as it's over 5, even if it's 1,000 or 2,000, it just starts reading and waits until watermark again drops below 5. Right?
Yeah,
so
but
there's no guarantee it will ever be bigger than 5, which I think is what you meant. The only guarantee is that if it's bigger than 5, it stops. But it could be 200, 1,000, whatever. But at that point, it'll stop.
Okay, so it will
It could
start 1,000 calls to the API, then one API call returns.
no, it will be all the time.
So it would wait until like
yes, I'm not expecting. And then it could go back from 4 to 1,000 potentially.
Yeah. All right.
I think that's how I would
Okay.
Yeah, the same thing which I expect from it. So, okay, thanks.